What's up, hackers? Welcome to TTI Live on a completely weird day, completely weird time. I guess Fridays aren't that weird, but it's weird for me to be streaming. Anyway, welcome. We're doing a little bit of a bonus stream, one, because I don't have work today, and because I wanted to basically redeem myself. I did not really feel comfortable with how the Wednesday stream went. I felt like there were enough technical problems that got in the way of learning, and so I hate when that happens. So I wanted to kind of try again with some malware analysis, and I have a couple of samples that I want to play with today. We're going to start with a Gootloader sample that, to Prax's question, where did you find this malware? This was a sample that has no identifiable data in it, but it is something that we encountered, right? And so basically the story with all of these is that you have SEO poisoning. Right? Let me switch this over to chill. You have SEO poisoning where people go searching for something, and then what they get is not what they expect. But this is a common tactic used by attackers, especially the Gootloader group, to get users to download a zip file or an ISO or whatever, and then the malware will be installed from there. So I have a couple of samples to play with here. But I want to start with the one that we were playing with last night. And let's just check on how the lab's doing. I'm setting it back up now. All right, we're rebooting. We're installing the updates for our victim. Will you share a little on how to safely share malware? So the first thing is go study Husky's Practical Malware Analysis and Triage course, PMAT at TCM Academy. That will teach you everything that you need to know about malware analysis, and certainly more than I do. But in terms of sharing malware samples, right, regardless of what form they are, whether they're JavaScript files, whether they're ISOs, whether they're executables, whether they're whatever they are, you want to make sure, first of all, that they're defanged. What that means is that you want to prevent the operating system from automatically executing them. Okay, so if it is, you want to change up the file extension, that's kind of part one, and then you also want to, when you are ready to share it, you want to put it into an archive, a compressed archive, zip folder, tar, whatever it is, but you want to also password protect it. You want to password protect it for a couple of reasons. One, to make sure that somebody who gets the sample really knows what they're doing with it. It's just one extra safety layer. It's not a guarantee, but it's best practice. The other reason you want to password protect the sample is because malware scanners, when you start sharing these things, are going to be looking at the zip archives and trying to unzip them, but they can't do that if you have password protected it. I mean, they can a little bit depending on how compressed the archive is. They'll still be able to analyze some strings in there and see if there's something malicious. But again, just a best practice. Now, in terms of how to share, it's really up to you. I think that depending on if you trust the folks, you can do some things over direct email. It's not always the best. I think in a professional setting, right, you want to have an internal private share, a file share where those are protected, backed up, all of those things. And that share is directly connected to whatever your sandboxing or analysis machines are. But then there's kind of two stages to that question, because stage one is how do you share the things internally for analysis, and then what do you do with the results? If you are authorized to share your results, please do in one form or another, whether you submit any sandboxing reports to, places like Hybrid Analysis or Joe Sandbox or Triage. That's great. If you can't do that, but you can provide the indicators of compromise, the artifacts that you discovered from the analysis, consider sharing those upstream, whether with an ISAC that you're a member of, or perhaps if you want to put it on an open source threat intel feed like Alien Vault. I'm a huge fan of Alien Vault. I think it's a really nice intel feed. And so whenever I have indicators that I'm authorized to share, I will definitely put out a pulse there. Because our org is actually pretty cool about allowing us to publish research like that. But maybe yours isn't, and there's good reason for that. Oh, come on. Getting Windows ready forever in a day. Installing all these updates. But that's fine. So we can start with taking a look at the sample as we were looking at it last night, or nights ago. And I'm going to hop over into my Kali machine here. And we'll start here with this sample1.zip. Not working in that space. I don't know what you mean by that space, Prax. There are a lot of places that might not have a reason to share IOCs, but what are good reasons to not share IOCs? If they're proprietary, right? If they're, first of all, if the work is considered by policy intellectual property and you can't share them, you can't share them, right? Depending on if you're like a research lab or something like that. Yeah, so there's like malware analysis and threat hunting that happens in orgs, and then there are places like security vendors like Huntress or Mandiant that do that professionally, right? And so if you work at a place like Huntress or Mandiant, maybe you'll do a security write-up, but maybe if you publish your own rules for like your own EDR, right? Say you work at Trellix or something like that, you don't want to publish those. Those are going someplace else. Now, those places do have open feeds sometimes, but there is a bit of a difference, especially for the higher levels of the pyramid of pain, right? The atomics they'll probably publish because they're short-lived anyway, and by atomics I mean domains, IP addresses, right? File names, hashes. Those things are going to be short-lived anyway, so they'll publish those. They don't really care. But the behavioral stuff, they sometimes will consider that to be secret sauce, and they won't publish those. So that's one reason. Another reason is if you're in an organization and the sample that you have was targeted directly at you, and the sample will have something that tells somebody else something about your organization, like even that it worked, right? That it got past your defenses. There are some reasons to not share samples for that reason. One of the reasons why I can kind of get away with a little bit more of that, one is because we have slightly more open policies about that, and two, I work for a public institution, so a lot of our stuff is like a matter of public record, and so that kind of how that works. Yes. Fun hole behavioral detections are harder to write and identify. They require serious research and often live samples, logs, incidents. That's right, which is what we're going to do today. That is correct. Yeah, Cephodius, that's right. Proxmox is our hypervisor of choice, and it's working great, even if this Windows machine is taking a bajillion years to update. But that's okay. As I said, we're going to start with the samples that I got. So the first sample that I have here for you is, it was a JavaScript file. And the way that the JavaScript file was downloaded, as I was saying, was through SEO poisoning. So somebody went and searched for something, and what they searched for resulted in this file, how to write a letter requesting legal representation. Now, if you try to search for that thing right now, like, we can try it. I don't know that it will result in you finding evil. How to write a letter requesting legal representation. I was trying to game this out this morning, try to see like how many things you could possibly find. So, all right. So what you want to do is try to see one of these that may ask you to download something, or that will redirect you someplace, right? And I'm kind of doing this in an isolated environment just to see where I get redirected. But what will happen often is that users will click on one of these things that has been brought up to the top of a search result. Actually, let me turn off all my ad blocking here too to see what that does to the results. And at some point, you may find one of these results that will send you someplace that will have you download a malicious file. Tegan had a search for LibreOffice that was SEO poison last week. Cool. Thanks for that one. Oof. Although I do appreciate somebody's using LibreOffice, or trying to. So what do we have here? And this was throwing Husky for a loop. We were talking about it last night. So what got downloaded? There was this is sample one. It's a zip file. So the first thing that happens is a user, when they download a zip file, they will double click on it because let's get out of the tech nerd zone for a moment. Most users don't know what a zip file is. Okay? Ask the folks in your marketing department, ask the folks in your business office, like, what is a zip file? You will not get an answer like, oh, it's a compressed archive that contains the instructions for reproducing a file, not the file itself, therefore it saves space, it uses algorithms to remove empty space, and then add it back in as necessary when producing the new file. They don't know what that is. What they know is that it's a folder that has other stuff in it, and that sometimes you have to click on it extra to open it up. So when you download a zip file, which we know is going to contain stuff that sometimes our scanning tools, like antivirus, won't be able to take a look at, they don't really know the difference. So you get a zip file, you open it up, and then there's going to be a .js file inside. In this case, there was a .js file inside. It's 2022, almost 2023, but to this day, if you write a specific kind of JavaScript file, or JScript file, really. Let me bring this over. It's Vim, the JScript demo.js. So check this out. So here we have a regular JavaScript function. And I'm going to delete this. A regular JavaScript function, right? But then we have JScript, right? Which is the JavaScript syntax hook into the WScript API. And you can see here the WScript.createObject, WScript.shell, and then we're going to pop calc with this, right? But there are a couple of things that I want to point out about this. First of all, I'm going to copy the JScript demo over to WinHome Downloads. Cool. So I'm going to fire this up, this JScript demo, and it's a JavaScript file, right? But because of JScript existing, when I double click on this, calc pops, because this file is executable to Windows. Couple things to notice though. This does nothing function is inside of this file, right? The WScript API does not have console.log. This isn't Node, okay? If you're familiar with JavaScript, this is not something that has console.log. This will not work. But the reason that JScript can still execute this file without errors is because the function is never called. And so, if I do in fact call does nothing, if I invoke this, and then I copy this back over, fire this up, so it still works, but I got this error too, right? The Windows script host says that console is undefined. And so I wanted to put that context out there because the tactic that Gootloader has been using, and I think a couple of other groups are using this as well, is that they are taking legit JavaScript libraries and using that as their obfuscation starting point. In this case, they were using chroma.js, right? JavaScript library for color conversions. So you got chroma.js here, and this is the sample, right? How to write a letter requesting legal representation. This is what it is. Now, as we start going through this, it looks like JavaScript, okay? And we see some stuff that obviously is doing color math, okay? At some point, though, you will start noticing some pretty weird functions like number u and this thing here. So all of a sudden, you start seeing these functions that have totally nonsensical names. And as you continue through the file, you'll start seeing these string concatenations that are obviously weird. The indentation doesn't match. There are visual indicators that something has changed between these two files. Now, I've also run a diff, right? If you run a diff between these things, what you will find, I'm going to send this to diff2. What you will find is that there's a whole bunch of differences between the lines. Now I have to clean this up a little bit to make it work like JavaScript. You see all these errors here because of these right column lines and these line numbers. But these are all the different functions and variable assignments that the malware sample has that Chroma did not have. I did that pretty quickly. Just be aware. So diff, suppress command lines, chroma.js. So I'm taking the legit chroma, how to write a letter requesting legal representation. Prax is asking, are you using Linux subsystem? It's Windows subsystem for Linux, not Linux subsystem for Windows. I know that name is weird, but there's a reason it's that way. We can talk about why it's Windows subsystem for Linux, not Linux subsystem for Windows. But it's WSL. And no, I'm not. I am using a Hyper-V virtual machine that is just Kali Linux. A lot of folks ask me why I don't use Remnux or another kind of specialized malware analysis VM. And the reason is I don't want to set up a whole other environment. I use Kali all the time. One of my most common work functions is web app pen testing. So I'm going to be I do Kali. I have all my tools loaded in Kali, so I'm good. But it turns out that the Kali repositories also have pretty much everything that you need to do certainly static malware analysis. And if you want to set it up to do some dynamic, you can do that too. So for that reason, why go set up a whole other thing, right? Or set up a new environment. I have a Kali machine, or I have a Kali setup that I have scripted that I know well. And I feel like working in a comfortable environment is of higher priority to me. Every time I try to use Remnux, it drives me up a wall. That's my mileage, yours may vary, but I found that Kali works well enough for the kind of work that I'm doing. So I have Kali. Now, this terminal that you just saw here while I was doing the JScript demo, this was absolutely Windows subsystem for Linux. WSL is the best way to experience Linux? I guess. I mean, I'm a Linux daily driver, right? My primary computer that isn't the streaming rig is a Linux machine, and I've been using Linux for over a decade. I think that I would lose my mind if I did not have WSL on my Windows machine at work. Because almost everything that I end up doing is in WSL, whether I'm working in Vim, whether I'm working in Jupyter Notebooks, whatever. Oh, finally. Okay, so this is up. And it ran. Let's see. Do I have agents reporting in? The analysis agent is reporting in, but for whatever reason, the victim didn't run. So I'm going to fire this off. I'm going to run the Ansible playbook again, but I'm going to limit it to victim. Just make sure everything's good. 10.1.5. Fleet server token is wrong. I got to recopy that. 10.1.99.105. The fleet server token for enrollment comes from here. By the way, for new folks, what we're doing is we're spinning up the entire Elk stack using the Elastic Container Project. And so it's all done in Docker. It's all pretty much automated. And we just have to tell the Ansible playbook for the analysis machines how to install the Elastic agent to talk to our server. Once that's done, we will see agents reporting in. It has already been configured with Sysmon, so we have all of the logging that we're going to need for today's work. All right, as this goes through and figures itself out, Chocolatey should be... This should be quick, I'm hoping, because all of the long stuff has already been done. The Malware Lab playbooks also do have provisions for doing a Kali machine as well, if you want to do Linux analysis that's isolated. We're not bothering with that right now, but you can absolutely do so. And RDP is enabled, so we can connect right to the Malware Lab victim. Now, this is my jump box in the lab. So the way that the jump box works is we are RDPing into the jump box. The jump box is in an isolated network with the malware lab machines, and then from there we can further isolate anything that we execute malware on with firewall rules in Proxmox. So if we look at the firewall rules in Proxmox, I have a security group called Malware Lab. And what this does is it allows RDP and SSH from my jump box, and it allows nothing else to or from my infrastructure network in the lab or my home LAN. Okay, so none of those IP addresses will resolve. So I'm not like fussing with firewall rules in my router because it's easier to do it here at the hypervisor level, but I could do it in the router if I wanted. But I have this security group. So what's cool then is that I can go over to my Malware Lab machines, right? And enable the firewall, like turn it on. And once it's on, insert the security group of Malware Lab and enable that. And then that's it. We know that this thing is isolated the way that we want it to be. Now, you might wonder, wait, Taggart, why are you letting it talk to the internet? I need it to talk to the internet. I actually need this malware to go hit the domains that it's trying to get because I want to see what it's actually doing. It can't hit anything else in my network, and I'm not worried about this machine, right? It's a burner, so that's fine. All right, now we're installing the agent. How are we doing here? Should be almost done. Let's go back and look at our static analysis a little bit more. So what you'll start seeing as we reverse this is it's a hot mess. I was doing a little bit of reversing of it last night, but the truth, or 2 nights ago, the truth is though that it's so obfuscated that personally I don't think it's worth it. At this point, trying to deobfuscate all this JavaScript and figure out what it's doing, like, I am going to be able to hit this, I'm going to be able to discover what it's doing dynamically, which is really what I care about anyway. What are the behaviors? Because I don't give a rip about the hash of this. I'm not doing one of those security write-ups from like Sophos or Red Canary. I'm not going to be like, well, you can see here at this line in the deobfuscated PowerShell it does this. I care about what it does, not necessarily how at this point, because I don't think it's going to be complex enough. If I totally can't understand via dynamic analysis what it's doing or how it's doing it, I will absolutely go back to static to see like what is exactly in this code if I have to deobfuscate all this. But it's such a mess here that I'd really rather not if I can avoid it. But this is the first payload that we get somewhat cleaned up. We have a bunch of different functions here, then we have a bunch of concatenated strings, and somewhere along the line these are all cleaned up, base64 decoded or whatever. We have a bunch of these things with a lot of backslashes in here. I suspect this is padding, and we can just kind of remove those, but clean all of that up. And then you will have what will amount to Windows script host commands. That's what it is doing. Okay, the Ansible playbook ran. If we go over to our fleet, we have a victim phoning home. Now let's go over to our Discover page. Hey, November. Let's clean this up. Let's see data coming in. We indeed do have data coming in. And if we look at agent.name, there's win analysis. I don't see win victim yet. Should be here in a couple of minutes, though. Let's run something on the victim. Let's actually connect to it. And I'm mounting the samples folder from my jump box so that I can load files directly onto it. Okay. And actually, I'm going to clear this whole filter. I just want to be in Discover. Is Elastic something like Splunk? It is something like Splunk. Elasticsearch is a Java-based search engine, and that is what allows us to run queries against data sets. The data sets come from different sources. In this particular case, we're using something called the Elastic Agent, which lives on our systems to connect to Elastic. But the web interface that you're seeing here is not Elastic, despite the branding. It is Kibana. Kibana is a front end for Elasticsearch that allows you to run different kinds of queries and visualize your findings. So that is why it's often called the ELK stack. The L is for Logstash, which we aren't actually using. Well, we are under the hood inside the Elastic Agent. So those three things make up the ELK stack, but it's now called Elastic more than it is called the ELK stack, or that's what they want you to call it. So at any rate, something like Splunk, yes, it is absolutely a security information and events monitoring system. It has some different limitations. I'm a little concerned why I cannot connect. I can't see the agent here. So I'm gonna SSH to it, because all of my machines have SSH as well, including the Windows ones. It makes it really easy to manage. That's how Ansible works too, by the way. I don't mess with WinRM. Okay. I'm gonna try this again. Okay. Now we're gonna run. I need to get the fleet data. Yeah. Something's up. So we're gonna go to fleet and make sure this thing is enrolled. And actually, I want to make sure I get it right. So if I click add agent, we are given a command to run, and it's going to be something like this. And we also have to give it a -i for insecure, because we're not trusting the... And what I found out last time is if I run enroll, successfully enroll the Elastic Agent. Okay. And if I run install again, no, I think we're good. Okay, so we got a new win victim. Let's see what this does. There we go. We might have to unenroll the old version here. Yeah. So we're going to pull these off. Actions. Unenroll. Force remove agents. Cool. So now we have this one. It's phoning home just fine. Everything looks good. Now let's go back over to our Discover and make sure that we have data coming in. Okay, I don't know what that's about. We will... So we have sysmon data coming in. But from where, right? Agent.name win analysis. We're definitely on win victim here. I am at a loss. Oh, no, I'm not. You know what I forgot? You know what I forgot? I forgot to add to the firewall rule to allow communication to the server. If I... Testing. Did I kill stream audio? My audio looks good from here. Yeah, if I... Yeah, I forgot something important in the firewall. We're going to allow out to 10.1.99.105 protocol TCP. And from the isolation lab. And we're also gonna allow on 8220. Let's make sure that that was propagated down to our victim. There it is. Firewall rules. Okay, so we have our victim speaking to us now, and we can exit out of this. All right, let's detonate some malware. Before we actually detonate some malware, though, very important thing that we need to do, we're going to snapshot the system. So this thing is nice and clean, so we're going to take a snapshot here. I'm not going to include RAM. And that way, we'll be able to go back in time after we detonate malware and have another clean install. Now, I'm not capturing the memory. Okay. Awesome. So now, let us execute some malware. What I'm going to do is I'm going to move our sample from my mounted drive, and this is going to be sample 1. And yes, Defender is on. Over to my downloads folder. Okay. And I will run this just like a user would. And we're sort of repeating what we did on Wednesday, but I think it's important to show this. Now, before we fire this off, I want to make sure that Elastic's configured the way that I want. So first of all, I'm going to kick up our time window here to the last, not 30 days, last 30 minutes. Okay, and then let's do a little bit of filtering. We're going to filter for agent.name. We know that we want the victim. And we also are going to pull in some specific event codes. So the event.code that I want is, I'll add the filter here. We have sysmon installed, right? And if you're not familiar with sysmon, it is sort of a DLC logging capability. It's from Microsoft, but they don't ship it by default, but it's part of the sysinternals tools by Mark Rusinovich. We want event code 1 from sysmon, that is process creation. We want event code 3, which is network connections, which is really nice because it shows you source IP, dest IP, source port, dest port. It'll also try to show host name. But we also have DNS queries. So we're going to, in event ID 22, so we want that. And we also want 1322, we want 11 for file creations. Any files created, that'll be event ID 11. We have also a couple of special ones that I want. I want to look them up to make sure that I'm getting them correct. It's been a while since I've used Elk. Are you able to search in multiple indices like you can? Yeah, no. Not quite. The index is set here, HTTP, and so you're kind of in one at a time. But I would also say that Elastic indices are slightly different than Splunk indices. So the odds are good that you're going to be in one at a time for what you're looking for. It's let me put it another way. See how I'm matching a log index pattern here? So I am actually searching multiple indices, but like there's logs versus metrics, right? So I am actually searching multiple indices, but it is still pre-categorized. It's not like everything under the sun. So sysmon event IDs, I want there we go, 19, 20, and 21. WMI events. Clicked out of the filter creation. Okay, so let's just go through that again. Is one of 1, 3, Network connections. Let's do 22. DNS. 11 for file creation. 18. 19. 20. And we're using Swift on security sysmon config, which does track those. Then we're doing... Oh, right. There's one more. 1, 3, 11, 22. There's one more that I want, and that is event ID 4104. This is not from sysmon. This is going to be PowerShell invocation. I can imagine some complications when you want to build complex queries, like if you wanted to correlate proxy traffic with Windows process events. No, not really. It's totally fine. Because again, the way your index patterns work is that it's going to be like logs versus metrics, or something. You can make other data views, but it's pretty much going to be an index pattern like this, so all your logging is available to you. So no, it's really not that tricky. And you have other fields that you can kind of filter on for doing those ORs if you want, right? You have data.stream.dataset, for example. See how I have Windows sysmon operational versus system? So you can use those for your filters as opposed to the index. Slightly different. And to be honest with you, I often do that in Splunk anyway. Like I'll do source type as opposed to index to do a little bit different kinds of filtering. Okay. Now we have our filter set up. Let's clean up our columns a little bit. So I want to show event.code, obviously. And for the things that have it, I know that I want the process.command line. And then I want the process.pid. I want the process.parent PID. And those are just for event ID 1. When I have event ID 11, that's a file creation. I'm going to want the file.path. You can see sample1.zip is right there for when I wrote that to downloads. Okay, file.path. I'm going to reorder these a little bit. I'm going to put the PIDs at the end. Okay. Very good. When we have network connections, we'll have more stuff to show, but I think this will do for now. We have our snapshot. Everything's clean. We're ready to detonate our malware. So I'm going to open this up the same way that users do. I double-click on the zip folder. At this point, I'm not really in downloads anymore. I'm about to be in someplace else. When I click on this JavaScript file, I'm going to open up a new folder here, and I'm going to go to the app data folder in Windows, and local. It takes me to Romeo. I want to be in local and temp. Okay. And then watch carefully. I double click on this, and immediately this new folder appears, this temp1 sample.zip, and look, it has this here. This is what happens when you execute or you open a file inside a zip folder without properly extracting it. Windows is doing the extraction for you in the background and tossing the results in app data local temp. And so when you are looking for artifacts from malware execution like this, don't forget that you should be looking at app data local temp for this reason. All right, let's see what we see. So this is the first thing that has happened, is the wscript.exe kicked off. When I double-clicked on the file. So wscript.exe, the Windows script host, picked up the JavaScript file and is attempting to execute it. That's what happens first. Let's see what comes next. Okay, so far not much. We also know that there's one of the things that we found in the original dropper is that there's a sleeper. So there's a timer on the JavaScript file to kind of wait for a while before doing anything. And so kind of trying to outlast that. I don't need a tour. And this DLL host. This did happen, so what was this? This may be totally unrelated, but it's here, so we'll take a look. ID 9F15673. And you are... Yeah, I don't think there's a relationship between that DLL host and here, or at least not one that I can easily see with sysmon data. Still waiting for more information to come in here. I believe that there is still a Windows script host running. So we're still just waiting for that to detonate. But just in case, I'm going to click on it again. All right, there's the second W script, right? Ah, so interestingly, the first one didn't work, but the second one did. So that was the first one. I was just impatient. So the reason I know that it came from the first one is because this is our process creation, right? And then 1088 was the parent PID. And then if we look for... Oh, actually, just kidding. 1088 is task host, right? So maybe it was the second one. But now we have something new that has happened. So first of all, we see a file write to see Windows System 32 tasks conductivity meter. We have a new scheduled task that has been created. And what's really interesting to me about this... Yeah, no, this was 45. This was the second run. The second run did it. The first one didn't. What is interesting to me about this is that conductivity meter is a scheduled task. We didn't see the scheduled task creation occur. Right? Meaning they didn't use scatasks.exe to make this happen. 19, 20, 21. I was off by one. Let me change that filter then. Okay, some more cool stuff has happened in the meantime. So what has happened? So first of all, we see tasks conductivity meter, the scheduled task has kicked off. And then there's this other thing going on. There's this new process that's this vocabu_1.js, right? What has happened? Well, a scheduled task has been created, and it has been created with a pretty interesting configuration. If we look at what's happening here, we'll go to the message of the process creation. You can see that the command line is cscript.exe hitting this .js file, but look at the current directory, c user seclab appdata roaming /adobe. And if we look at that location, there is indeed this file called vocabulary development, which we've already captured. And look how big it is. It's 45 megs. So what's going on with this? Well, we've already captured it. So I can show you in our Kali box. This is vocabulary development. Actually, this is vocabulary development cleaned up. Without all of this, it is one big file, and at the very end of it was just megabytes and megabytes of noise, just filler. But after that was all cleaned up, and I just did that so it was more readable. We have more of the same kind of obfuscation that we saw in the first stage. So this is kind of the second stage. This is the persistent one because it's part of a scheduled task. Now again, I'm not exactly certain everything that is going on here, but I do know that the very next thing that happens after this is dropped and run is this PowerShell invocation. Look at the look at the weird like up down camel case PowerShell. So what's happening here? PowerShell is being invoked, but notice that it's being invoked without a command line argument. How is that possible? It's possible because what's actually happening is that it's being given a PowerShell script to run. Well, can we see the script? Yes, we can. And the reason we can is because we're looking at event ID 4104 for Windows PowerShell script block logging. So look at the path we're taking here. We have vocab tilde1.js. By the way, chat, does anybody know what that tilde1 is all about? These are the old magics. Does anybody know what that tilde1 is? Why is that happening? Why does it work? Version? Yeah, so that's a good guess. Like when you save a copy of the same name instead of the one. So this is the old magics. This comes from DOS, actually. In DOS, you could only create names with up to 8 characters, right? And so if you had file names that were longer than that, but you needed to reference them in DOS, hopefully they were unique up to the first 8 characters. And what happened was you could use the tilde1 to sort of be like, and the rest for your file name. Anything that matched that. So we can actually see that happen. So if I'm here, I'm in my documents folder. If I cd DOW tilde1, or do I need a command shell to work with this? Maybe a command prompt will work this. cd DOW tilde1. Come on. DOW tilde1. Is it case sensitive? Come on. I know that this works. Maybe I'm not it's been a long time since I've used DOS, but that's where it comes from. And so what's happening is it's using that to autocomplete the file name. It is referencing vocabulary development.js, but if you're not familiar with that, you won't see it show up here. That is actually absolutely right. All Windows versions are backwards compatible. Now, the question I still have is, how did it drop this without leaving a trace? And I thought for sure it was through WMI, which is why I added the 18, 19, and 20 event IDs. But I'm not seeing them, and that might be because the WMI stuff isn't enabled. I might have to enable WMI event tracing, excuse me, to see it. That is my remaining question about the first stage. How did it drop this? How did it create the task without me seeing it? But we can see now the third stage, this PowerShell. What is this? Because we have Windows, or sorry, if we have 3, 2, 1. Because we have PowerShell script block logging enabled, we can in fact see the whole thing. And this is much, much easier. I love that the Gootloader folks got lazier with their obfuscation at every stage. So this, we're actually going to just take and directly clear up. Can I Goot.ps1? Can I paste from here? I can. Okay, so we're going to save this thing as Goot.ps1. Hey, Triple Helix, thanks for the follow. It's one line. Now, I'm using VS Code, but actually for what we're doing here, Vim is a little bit easier for me. So what are we going to do? First things first, we are going to, anytime there is a semicolon, we're going to replace it with a semicolon and a line break. I forgot the global. There we go. Never heard someone say Vim is easier than VS Code? It absolutely is, though. Okay, so now we have multiple lines. We can do better, though. So now I also see some lines that have a space at the beginning. %s. And I want those out. Okay. Looks like I broke the user agent here, so we'll fix that. If you can memorize the short, the thing is that there are things that you can do in Vim that you absolutely just can't do in VS Code. Like the kind of dynamic find and replace. Like even though it has regular expression capabilities, they are not as complete as they are in Vim, and so I prefer to do this stuff in Vim. It requires some shortcut and regex wizardry. I have some great news for you. If you want to learn regular expressions, I have a course on it. Actually, there's regular expression stuff that we do in both the Intro to Regular Expressions and the Python for Defenders courses. So if you're interested in those, you should check them out. And I am planning on doing a small course on Vim soon, because it's for me at least part of the base tool set. I use Vim every day for actual defensive work. It is an invaluable tool for me. All right, we can clean this up a little bit more. What we'll do is anytime there is a left bracket, we will replace that with a left bracket and a tab and a new line. Not necessarily in that order. Hey, Ken. Good to see you. And then anytime there is a right bracket or right curly, we're going to replace it with a right curly and a new line as well. It would be nice to know more about Vim than :W::WQ. All right, well, I'm going to blow your mind right now because there's another easier way to save and quit. Okay, this looks pretty good. So what we'll do is we will save and quit with :X. And if, in case you're wondering why that works. Nope, wrong thing. :X is like WQ, but write only when changes have been made. Yeah, as I was saying, Triple Helix, you can do this in VS Code, but it's really annoying to use the find and replace thing in VS Code. As a matter of fact, my regular expressions course shows you how to do this both in Vim and VS Code for that reason. Okay, so we'll get out of this. And then we'll open this back up in here. And then the one last thing we'll do just to do a final cleanup now that we can see that a little more, and this is something that VS Code does have over Vim for this, certainly, is the format document capability, right? So now it's nice and clean. I mean, there's still some work to do here. And if we try to paste all this in and do format document, how does it do with it? Yeah, see, if we try to do it all by automation, it doesn't work. So a little bit of manual cleanup goes a long way here. Okay, so now, oh, hey, Fafin, good to see you. Now we're into the actual business of deobfuscating this thing. And frankly, it's not hard. It's really not hard. Now I am, okay, so that's there. There's some funky indentation, but I can live with it. Mostly. I'm just cleaning this up a little bit. All right, that looks good. That looks good. This catch is pretty goofy. And right, okay. Sleep. Okay, that looks good. All right. Let's clean this up a little bit. We have some ridiculous names. So this is our primary wrapper function, right? And you can see that it's getting called. By the way, here's your atomics. Here's some domain names for you, which we will see in short order, by the way. But for now, if you want these atomics, I'm going too fast. There we go. All right. The XML rpc.php files in every path seem interesting. I'm surprised they hard-coded the payload file name. Yeah, it's pretty lazy. Okay. And then we'll defang it here. And we'll save that as our domains.txt. Nice and clean. Okay, so what does this thing do? So our primary function, we're just going to rename this to do evil stuff. Cool. Now, we have this initial string here of a key, and I'll leave that as is for now. What does this function do? Well, let's take a look at the inside of it. Even though it's made these memory or these variable names kind of interesting, it's obvious what this is doing, right? It's creating a memory stream. It's creating a stream writer to that memory stream. It's writing stuff to it. It's using gzip compression, and then it's base64 encoding it. So we kind of know that this is doing like a B64 zip encoding. That's basically what's going on here. So here, this is the memory stream. And yes, I am using VS Code for this because this part it does better. I use the right tool for the job. It does this, I feel like, way better, especially with the multiple cursors. And then this is going to be the stream writer. There we go. Starting to look clearer now. So then the question is, like, what is all of this? Well, it's doing some PowerShell to get information about the system. So what is happening here? There end where value.length is less than 100. Type to name, and then with OSWMI, this is the OS. So it's getting OS information. You can right-click on variables and rename the reference across the entire document. That's not as cool as the multiple cursors. Also, I actually think, I'm not sure if I'm missing something here, but I think actually this is faster. So here, this is operating system. This is GPS. This is processes, right? Get process. That's the other alias. And oh, this is windowed applications. And I'm just looking at the PowerShell here and reading through what it's doing because it didn't obfuscate any of this. The hotkey is F2. Not working, and it's fine. So this is a little bit interesting, right? These are applications. But it's also like installed apps, really, is what this is. And then this one here is GDR. These are drives. Get drive, or get PS drive is what the full command is. Okay. And now we just have one thing left, which is our web request. And what is this situation? This is the cookie SGDBI. I think this is just the cookie val. We'll call this cookie val. because it's adding the cookie val, right? And then it's concatenating the cookie val with other stuff. It's setting the cookies in the web request to all the data pulled. Exactly right. Exactly right. And then getting a response. And then response data. And if there are 3 responses, when we split, it's splitting on whatever the cookie val is. And then if the response is equal to, the count is equal to 3 in that array, it's invoking the second one, replacing whatever it finds these carrots with nothing. And that's the part I haven't seen happen, but that's what it's doing. This is what it's supposed to do. Now, this cookie val that starts, right, is... This is where it gets defined. And so this is kind of a key, but it's also a delimiter. In fact, I might rename this to cookie key. To make that a little bit clearer. And so what you see is that it's using that key as a starting point. And then, so that's part 1, and then processes, Windows applications, install, drives. Okay. Now, let's go back over to our dynamic analysis and see what we've observed in the interim. There should be quite a lot, actually. Really? No? Nothing? I'm unconvinced. About this. We should be seeing a whole bunch more stuff. I'm unconvinced that everything is configured the way it should be, because I'm seeing only event ID 1. I'm not seeing event ID 3. That should definitely be happening. Right? None of that is occurring. A lot of stuff from PowerShell, though. Provider function is started. Yeah. I do not think sysmon was configured correctly on this machine. And the reason I think that is because I should be seeing network events at the very least. Let me confirm I have internet access here. Freaking Edge. That's a big yes. So I have network connections, right? Or I have internet access, and if I go to my application logs here, This will take a second to load. We could also do this via PowerShell, but it's a little bit finicky for what I'm trying to do, so. Hey, the Logros, thank you so much for the follow. Right, so we're going to go to Microsoft, Windows. Then we're going to go to Sysmon, Operational. Yo, what the? Look at that. The data is here. Right, we have event ID 3s, we have it, and we have 1s, but we also have, that was my network connection. Did the malware not do any of it? I refuse to believe that that's true. Chinaworker.info. It is happening, but we're not seeing it in Elastic. What is up with that? Let's try this filter again. Event.code. And maybe we're too far out of time, so we'll say is one of. Again, so 1, 3, 22, 4104, 19, 20, 21. It's not seeing 21. That's fine. And 11. All this MS Edge stuff. I'm gonna go last hour. Are there good ways to test Elastic and Sysmon implementations on an ephemeral machine before firing off the malware? Well, we did that. We did that. You could do network connections. And it's the same config that I've been using. It's 10:30. I, honest to God, do not know why this is not reporting correctly. Because we know that we saw... Look, this is all 1 and 11. Right? And then 4104. But we know that there are network connections that were taking place. We know that there were. We saw them happen. So I am unclear as to why stream is coming up on 90 minutes. I expanded it back to an hour, Prax. And the thing is still making connections, right? If, like, take a look at this. This is from 11:10. It's 10 minutes ago. No, something's up with the filter. There's 13. Are you filtering out those events from the Elastic Agent? I swear not on purpose. Hey, Matt. Like, this was working, the same config, last night. That is very odd. Well, since we're in the event viewer, we can see all these network connections, right? And we can see these DNS queries. So we actually see that it's using the domains that we were looking at. It's trying to make those connections. But the real question that I have is whether it's a lot of registry stuff. Good old registry data. You're so helpful. Create remote thread. That's fine. When did we fire off our evil? Let's get our victim back. Okay. Event.code. Is one of 1 3. Like, it sees it in there. Just do that many. Lot of process creations because I just did a bunch of stuff on the system. But now we're back at 10:30. So where's our buddy PowerShell? Here we go. So we're talking about 10:50 about is when stuff started kicking off, right? And by rights we should see, oh, look at this. There's like 10:54. There's a 6-minute block of missing data. Which might, but we should still see incoming data. Everything's healthy, right? Yeah, everything's healthy. So, okay, so 10:50, we can still use this view at least. It's not as fun, but since we're looking at syslog specifically, right? Plenty of stuff going on. So here we start seeing DNS queries, right? But what we do not see so here's our process creation. This is WScript, right? So here's the vocab.js. The next process creation should be C-script, okay? Then comes PowerShell. Then comes PowerShell, right? And then comes the PSScript policy test.ps1. Then come a bunch of DNS queries. Now, we're not seeing the 4104s in here because they're in a different section. And we do not see the scheduled task creation. Hey, Ginge. But we do see the network connections, right? We see plenty of them happening. right? Network connections from PowerShell. And over time, you'll start to see the DNS queries go away because they'll be cached, right? Hey, Christy. And these match the domains that we saw, right? RelianceSmartPoint.com. So we know that we're catching the data. I am not sure why. Elastic is being a big old jerk about it. But what I'd like to do is bring this thing back to start. And the one thing I want to try to do before moving on from this sample I didn't see any sim evasion in the malware. Maybe that PHP grabs. Frax, this was working last night. Like, we saw it happen, and the data came in. There's something going on with Elastic that I'm not entirely clear on, but that is the issue. The malware itself is a known quantity at this point as to how it shows when Elastic is working. But I do want to know what's going on. Because if it's using the Windows script host to do WMI stuff to set schedule tasks, we should see it somewhere. Okay, on the view menu, click show analytic and debug logs. Look at the trace for WMI. All right, yeah, let's do it. Let's see if there's any. Show analytic debug logs. So much more stuff just came up. Okay. My God. So what are we looking at exactly? We want applications, service logs, Microsoft Windows, WMI activity. Application service logs, Microsoft Windows. Okay, so close to Sysmon. So application service logs, Microsoft, cancel, Windows. What was the other thing? WMI activity. Okay. Come on. Show me WMI activity. And then after that, I can't help but notice that it's not there. Is there a thing you need to do to enable it? Enabling WMI tracing. Yes. Okay, we need to do that. So what I'm going to do is we're going to bring this back to 1. We're going to reset. That's why we took a snapshot of this. We're going to roll this back, which I hope disconnects our VM. It's concerning. Oh, good. There it is. I was like, that better disconnect the thing because it's supposed to reset the system. Okay, so we'll power the Malware Lab victim back on. And now we have a clean system. We'll rerun our executions. But before we do anything, we will enable WMI event tracing, which is also something that I'm going to add while I'm thinking about it to... Yeah. Not Elastic Agent. I'm going to add it to the Malware Lab analysis win tasks. Yeah. Name, enable WMI tracing. Are you tracking 4698 in Elk? Not right now. Schedule task created. That's a good idea. I should check that. That is a very good idea. I will look at 4698. I was so focused on Sysmon, I forgot about that. Let's add 4698. And so that should be back at the 1050 zone. But again, weirdly not coming in, even though we know that it happened. And we do know, like, we can check the integration, but I know for sure that the security logs are coming in, so that shouldn't be an issue. That's okay. So our victim is back up. How do I know it happened? I saw the task. First of all, I saw the file right here. Okay. So first of all, I saw the file write to see Windows System 32 tasks. So that's one. Two, if we look through these, we'll see. If we had run the get scheduled task, it would have shown us the scheduled task there as well. But the big giveaway from this set of logs was the write to the System 32 tasks, which happens when you create a scheduled task. And hey, maybe that's actually how they're doing it. They're just dropping the file. I wonder if that works. No, because it was service host. So it was service host that did the writing, which means they did it some other way, either through WMI or whatever, but we didn't see exactly how that happened. Okay. But we're going to run it again. But before we do anything, I'm gonna SSH to this thing. Okay. And we're gonna run this. Okay. So WMI tracing is enabled. That's pretty cool. Ansible.windows.win, what is it, shell, I think? Win command. Command. Yeah, I can just do that. Oh, and actually, probably do like an F too, right? Enabled quiet. There we go. All right, so now that's part of the setup for our machines. I'm gonna stay logged in here, just so I have an easy command line, much easier than going through RDP. And now, let's do this again. Yeah, I'm going downloads. Okay. This time I will extract it to see if it does anything different. Okay, we're off to the races. How we doing? Now I'm not getting any telemetry at all. Oh no, is that because the time didn't update? It thinks it's 7:37 p.m. All right. One of my practice leads insists on setting all logs to Zulu. Yeah, I get that. Yeah, look, we've got a bunch of stuff. That's really funny. Okay, so we've got WScript doing its thing. And again, the first click doesn't run, but the second one seems to. Look at that. Okay. So there's your... Okay, so there's WScript again. Search the logs of the future. That's what we're doing. Did it finally update its time? No, it did not. Oh, sorry if you can hear a landscaper. This is what I get for streaming at a different time. That's super annoying. Good. I'm glad that you cannot hear it. Is Defender catching it? Like, what are we doing here? Oh, Defender might be catching it. It's just to throw off the OSINT. Somebody wanted to find me, they could. That's, no, nothing going on here. What's your deal? We're seeing data come in, which is encouraging, right? Oh, there it is. There's WScript exe. There's the task drop, by the way. We're still not seeing anything but like event ID 1 and 11. But there's your conductivity meter, right? There's the task drop again. Okay, here's C script doing its thing. Okay, so we're getting there. We're getting there. We just need to see PowerShell, which should be coming up. Okay. This is Windows doing update stuff. This is Defender updating its signatures while malware is running. So we're like in this zone here. Okay. All right, there's the PowerShell run. We should be seeing a 4104 next. There it is. Thank heavens, we're finally seeing DNS requests. Okay, this is good news. Filter for value. No, that's not what I wanted to do. Oh, that's WPAD? All right. Well, I don't care about that DNS question anyway. I do, however, want to toggle the column in the table and answer. Oh, hey, look, network requests. That was the question. I don't think we saw a response from that one. Oh, there's gets.co. There we go. Now we're getting somewhere. Yeah. And then there's the answers. Okay. And we're seeing network connections. So with network connections, I want the dest. And the dest port as well. So right away, you can see that connection. Cool. This lab is pretty great when it works. All right, so we're seeing these network connections, and we know that this thing from our PowerShell investigation is cycling through all of these, and then it's trying to see if it gets a response of a certain shape from any of them based on the data that it's sending. It doesn't appear to be, and who knows why. Maybe it's all down. Maybe there's some reason that our data triggers something like, oh, that's a sandbox. Don't send them anything. Maybe that's what's going on. We can modify all this and kind of try to send it out in a different way, but let's go back and see if anything else appears. I still really want to know. So that's crazy that the WMI, we still got the scheduled task. And just to, yeah, so now you're seeing the cycling through the domains. Plain as day. This is what I was hoping we would see before. And it still hasn't updated time. We have to figure out why that is. We're gonna have to maintain an NTP server locally. Hey, Tokajit, thank you so much for the follow. All right, so this is doing its thing, but just to satisfy HGB's curiosity, get scheduled task. I'll make this a little bit bigger. Okay. Here come all our scheduled tasks. There's a lot of them. But if we go up to the very top of that list, hey, look, there's a conductivity meter. Having a domain controller in your lab with local NTP and domain joined victim computer might yield some better results with some specific malware analysis. Yes, that is true. When I do stuff that I have reason to believe is domain related, that happens. Okay, now, someone who wasn't hanging out with me last night, how do you get the path to the task binary, the bin path? How do you get it with PowerShell? How do you get it with PowerShell? Do not tell me tasks/query. I'm not asking that. How do you get it with PowerShell? If anyone knows, HTTP should know, I suspect. But it's something that I think isn't covered that often because everyone just uses tasks. But if you want to use PowerShell to do it, get scheduled task, conductivity meter. When we get that specific one, all we'll see by default is the task path, task name, and the state. But if I want where the thing actually, what the executable actually is, what it's running, what its action is, select to get into full properties. So that's the first part, right? It's format list. And it lives in actions. It lives in actions. So we have to select, expand property, actions. And that will tell us what it is. And so you can see W scripts, and then the arguments is using that autocomplete thing. Okay. More network connections. Hello, what are you? Oh, okay. Well, it's a .NET assembly thing. That's interesting. SM host. A lot of file creations. I'm pretty sure this is Defender's update triggering the triggering the .NET run. But what else do we got? Oh, right. So we wanted to take a look on the system for the WMI data, which is not coming in. And I'm going to real quick check the integrations to confirm that I have the security logs coming in. Because I thought that was a default, but we'll make sure. Yeah, so let's see. PowerShell, system on operational, forwarded. Huh. 'Cause, 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 PowerShell operational, forwarded. Windows perfmon and service metrics. But oh man, so this is missing a bunch of stuff. That is interesting. So what we would have to do for that is add the custom Windows event logs, which is dumb, but it's a separate thing. Yeah, see, custom Windows event logs. And we'll add that to an existing policy. But what Windows event logs? So the channel name. So we can pick it up. So I obviously want security. I don't know why they're not coming in. That's insane. So we want the security logs. Can I add more than one? Interesting. All right, let's take a look at what we have here, because we know we enabled the WMI logging, and I want to see that happen. But to Ishibu's point, let's see if that 4698 is there at all. That is in security, right? Not application. No, that's a 4600 series. That's gots to be here. Fill the current log. That ID. Show me 4698. Nope. So however they're doing it, I wonder if they're just like, they're literally just dropping the file. Because that's what we see them doing. That's interesting. Okay, but I do want to check the WMI stuff as well. Microsoft, Windows, here comes the large list. WMI activity. All right, here we go. And operational. Boy, this is a bunch of stuff. Okay, so in the 730 zone. All right, here we go. SimWin32. This looks like the antivirus stuff that the updates that were happening though. Here we go. Here's a consumer. Select from event QL. Nope. I don't think it's WMI. Okay, so let's go back to this file, right, that we know that we have, right? Let's go back quite a ways. Okay, here's PowerShell. C Windows System 32 task connectivity meter. All right, I want that, whatever that is. So we're gonna go just grab that. Windows System 32 tasks connectivity meter. So can you just drop a task here? I did not know that that was a thing you could do. But we're going to grab it. And I'm going to transfer it over to the Kali machine so that we can analyze it. I hope. No, not like that. Like this. Yes. No? All right, fine. Let's just open this up in a text editor here, see what it says. Yeah, okay, so it's just XML. So that's it. That's the trick. Let's copy this and put that in Kali. Are you serious? Weird clipboard shrubs. Okay, so let's see. Multiple instances, ignore new. Logon trigger. And then what is it doing? Right, so there's your W script, vocab. So that's kind of a cool finding, right? That the dropping of this file to a specific location, C Windows System 32 tasks, which, by the way, apparently you can just do. No? Okay, here we go. So authenticated users can write to it. And administrators can do all sorts of stuff to it. But authenticated users can do it. So that is bananas. Am I reading that right? Users should be able to create tasks with their own permission set. Yes, I believe that is correct. My issue is that it's in System 32 tasks, that there's no other place that it goes, and that you can just write a file to there, and then the task executes. So that's like a thing you got to watch for, right? You can't just watch for 40. We just demonstrated that it doesn't produce a 4698. Create a scheduled task ID. That's pretty wild. Maybe I'm overreacting. It seems like kind of a big deal. I don't know that everybody's watching for exactly this. Let's try this just to confirm this. Let's make a new thing. We'll call this evil task. And the command is going to be calc. No arguments. Run level least privilege. Okay, so here's what we're gonna do. SecLab. Now, SecLab is an administrator, and so we're gonna change that up a little bit. We're gonna make a new user on this system, right? User victim. I can't believe I just did that. Yeah, that's fine. Okay, so we have a new local user. That's cool. So then we will disconnect as the victim. By the way, in terms of remediation, let's say you wanted to remediate this system without, at this stage, right? If you've confirmed that it didn't get any more data, at this point, to remediate this system, to recover the system, what would you do? Step one would be to obviously remove the stuff that has been written. Easiest way to do that is unregister, schedule task. If I can type schedule task. Okay. Now, schedule task is gone. And then, right, you would want to remove sample 1. Okay. And then, of course, anywhere else that it lived. So, app data, local, roaming, right? And we know that it was an Adobe, right? So you need to remove it from here as well. Okay. And then, of course, Windows. I'm actually curious if the file is still there. If it's unregistered? It is. So unregistering the task does delete that file, but you can just drop it without registering. Okay, so that's kind of step one. We've now recovered the system. Now let's reinfect it with our scheduled task, right? So to do that, there's evil task. Cool. So we're going to disconnect, and then we're going to reconnect as victim. 1440 by 900. We're going to attach samples. Good. Definitely forgot a step. Users. Every time I have to look this up. Somebody in chat have it for me. Net local group, add group name. Oh. Thanks, Technique. Okay, I did have the group name, right? Just the order. Okay. Thank you, Technique. Wonderful. By the way, I love KRDC. I say it all the time, but I love KRDC as my remote desktop client. It's one of the reasons I use KDE Neon as my base for the jump box. So handy. This is the first login for Victim, so it might take a minute. Now, we actually have another sample that was given to us by Technique that we may want to play with today. And this is for Quackbot, I believe. Right? Yeah. So I might queue that up while we're... All right, cool. We're logged in. Let me just get this going. Cool. All right. Back to this, though. Okay, so we're logged in as Victim, and the whole thing that we're trying is... Can we take this evil task file, right? Can we drop it to C, Windows, System, 32, Tasks? Fascinating. Currently don't have permission to access this folder. If I do this just with like PowerShell, can I drop it there? Like if I put it in downloads. See ya, Prax. Thanks for hanging out. Okay, we're gonna CP evil task to C, Windows 32. Nope. tasks. Evil task. Absolutely worked. I can't read it, but I can move things into there. That's really funny. Okay, so if I disconnect and then reconnect, a calculator should appear. Oh, you're right. You're right. I can't see it. It is not scheduled. It didn't bump on me doing anything, though, which is interesting. Yo, but it is there. Look, it is there. So it's dropped. Oh, wait a second. I think I forgot a step. I did. I forgot to change the username. Okay, let's delete okay, we'll try it one more time. So victim, get rid of you. Okay, SecLab is gone, so all of that's good. Kate is a pretty good text editor, by the way. This is the default text editor on KDE Plasma, and I do like it. I don't use it often, but I am always happy about it when I do. Okay. So I copied this over. It's not listed there. But let's try. So if I log out and then log back in, does the task host kind of do a re-examination? No. There's something else about this file that we're missing. Enabled true, evil task, or new. I've been wondering if the command doesn't work because it's here. Although, like, WScript I don't think had the .exe on it, but nevertheless. Cool. Let's see. CP, evil task, see, Windows, system, two, tasks. Okay. One last time. And then, yeah, we're going to see if there's a way to, like, manually update schedule tasks. Oh, wait a second. You know what? I'm being really obtuse. Because I'm disconnecting, but I'm not logging out. An RDP sign-on is not the same thing as a logout. That was interesting. You see those bunch of command shell prompts open? I don't know what that was about. Get scheduled task. Still not there. So we're definitely missing a different piece of this, and this is kind of where maybe fully reversing that initial JavaScript is well worth your time, because I am still at a loss as to how it's dropping schedule stack. Now, other folks have done research on this, right? We don't have to start from zero. So Red Canary had a nice kind of this was right in embedded .NET DLL into HKey, current user software, Microsoft Phone username. Jit Cypher, hey, good to see it. But we didn't see any of this happen, right? I mean, we can check. Can we go back to the JavaScript? Yeah, we can. It's really gnarly. Like, this is where we were. This is the initial drop, and we had done some cleanup to try to, like, run the functions in order. But it's pretty rough. Use a deobfuscator. Yeah, I'm familiar with these. I've had mixed success. With this stuff. We'll give it a shot, though. So we'll give it the original sample. No, we won't, because that's all chroma. So we'll give it, here's what we'll do. We'll clean up diff2.js. That I've done nothing with. So we're going to say globally if it's AZ 0 through 9, commas, or any amount from the beginning, and that's all there is from the beginning to the end of the line, then we are going to delete those lines. Oh, that was goofy. There. Oh. There we go. That's what I wanted. Now, we are going to replace that with nothing. And we're going to kill these lines. Okay. That's cleaned up. There's like one piece that's off. Okay. We'll see how well Synchrony does with this. That didn't take long. Unexpected token, line 4. Did I not copy the whole thing? No, it was that I didn't copy the whole thing. Where's the deobfuscation? Is it supposed to be up here? Or is it this thing, the save? Yeah. That's kind of what I'm saying. Like, they're designed to beat these. It did some nice formatting, but it doesn't walk through the functions the same way, which is and clean up this stuff, which is what we needed to do. Okay. All right, Christy, what's your deobfuscator? I'm familiar with a bunch of them. Yeah, the one that I usually use. No. Let's see. I'm trying to find the one that I like. D4JS is the one that I usually use. but it's not that it's obfuscated in a way like this is the one that I usually use, but the reason it's failing is because it's not using these kinds of obfuscations. It is using something a little bit more bespoke, a little bit more custom, where all the functions are, it's not using like crazy weird JavaScript tricks. It's just that the function names are tricky, and then they are creating weird arrays, and then they're looping through it, and then they are kind of embedding nesting functions to make it hard to read. It's not obfuscated in these traditional ways. So that's why these don't work on this. And that's why you have to actually go through and understand what's happening. So like, we know that the scheduled task is getting dropped. We know that that's happening, but there is some other piece of it. I wanna just do a search though on that, right? Let's say like, write scheduled task to system 32. Like, no, that's not helpful. I create a folder task schedule and a task schedule library. No, that's not helpful. Jobs, task scheduler, and a schedule task consists of an action, a trigger, a principal, and additional settings. Right. It's not. You know what? I mean, I'm sure it'll lie to us, but let's give it a shot. No. So this is garbage. You can use the XML option to specify an XML file that contains the task definition. Is that true? Nope, that's nonsense. Is there a way? Create a scheduled task without using schedtasks.exe. Ah, without using, but it has no idea. Good job, robots. There we go. So you think it's using PowerShell? But we saw that it was the scheduled task was dropped before any PowerShell ran, 4104 or otherwise. So I don't think that's right. I wonder if it's a registry thing. If it's two things. One, you write the schedule task and then you add it to the registry. Which, if true, let's go back to our data set here. Our Elastic data set. And let's take a look at registry stuff. This is going to be a mess. I want to see the 4104s, but I also want to see 12s and 13s. And I need to see the path. And then registry dot key. Okay. So now for our registry stuff, I'm gonna take out the file path and the DNS stuff just to make it a little bit easier to read here. Because now we're just looking at registry stuff. Okay. Explorer. Wait, where are my registry things? Oh, this no 13. Bunch of PowerShell. Now this 4104. Okay, this is the evil one. So we found it. Okay. So before this PowerShell was kicked off, we are looking for anything registry related that this was doing that was interesting. Yes, that is how, JIT Cipher. Okay, so this is the evil PowerShell. And then what are we missing? Because we're still not seeing any, like, I'm not seeing anything here that would lead to registry changes, right? And is it the case? Yeah. I want to see if there's one for the user. So HKCU, software, Microsoft, Windows. Or no, is it Windows NT? Current version. So the user doesn't have it, but I do know that it's in LM, in local machine. So let's try local machine. Make this bigger. HKLM, software, Microsoft, Windows NT, current version. Schedule, task cache. Right, and I can't read that because I'm not an admin. Let's become SecLab again. PS exec it. And how would that help? I'm not attacking the machine, though. Like, I have another user. I can just do that. Software. PS exec is like a mess. And actually, it's disabled on this. Microsoft, Windows. Plus, I have an SSH thing if I wanted to. Angel, good to see you. And that's exactly what I just did. I remote connected with RDP. The reason why I did it was because I wanted to see what else was in the folder structure. Yes, I have an SSH connection and I can use that as well, but I wanted to see what was actually in here. NT current version schedule. Task cache. What you got for me? Okay, so there's... What do we have in login? Okay, so bunch of stuff here. But the trick is that these are class IDs, right? They're not going to be... I'm never going to use this again, Angel. This machine is ephemeral. There's no point in my adding it to the favorites. Hey, Cam. Good to see you. Thanks for the follow. Yeah, no, this machine is going to get blown away. So I'm not going to add it to the favorites. All right, so what we have here are class IDs. They're not super helpful. Boy, everybody's got a lot of recommendations today. Why not use sysinternal suite? I don't need it. The regedit is fine. I'm just looking at the registry. But you're not using my favorite tool. You're doing it wrong because you're not using my favorite tool. No, thank you, Matt. Exactly. Extracts the auto runs for you. Let's be clear about what I'm doing. I am not looking for auto runs. I am looking specifically to see whether there is a registry component of scheduled tasks. The answer is yes. It is by class ID, right? So those are registered. The question was whether just dropping a file to see Windows System 32 tasks was sufficient to register a scheduled task. The answer is no. Apparently. That there's some other piece that happens. Right? And that's the part that we're not seeing. Task scheduler has its own logs. That might be kind of interesting. No, Angel, it wouldn't. The point is that just bear with me for a minute, okay? There is a method to my madness here. C# reflection, like, chill. We might have to enable task scheduler scheduler logging. It's interesting that that's an option at all. Yeah, we're gonna turn that right on. With util. Yeah, enable the log, right? Yes, that's what we want. And there was a way to do that. Come on. Too far. SL, Microsoft Windows, WMI activity, trace, enable true. So we're going to modify that to do Microsoft Windows, what is it? Task scheduler, true. Okay. So we're once again going to reset this thing to its starting position. Let me disconnect the SSH so that doesn't get weird. I just came in, so don't really know what we're doing, but that won't stop me from making recommendations. Sorry, that was a little bit sharp. I apologize, Angel, but that happens quite frequently. What we are doing is we're analyzing a bit of Gootloader malware. What we know is that the thing is a JavaScript file. It fires off. It eventually will drop a scheduled task, and that's the thing we don't know how it's doing, because it's not calling out to Skatasks, is not doing PowerShell, right? So there's some other method by which it is creating the scheduled task. But what we do see is a file write of the task XML to see Windows System 32 tasks. So the question is, is that file write sufficient to register a scheduled task? Seems to be the answer is no. Even though every user on the system can do it, can write to that folder with an XML, that's not enough to make a scheduled task. Something else is happening. And so what we're going to do now is enable the full logging for the task scheduler, which wasn't enabled before, to see what happens at that point when the payload runs. All right, so once more into the breach. Now it says that it's 8:48 or 8:49 p.m. It's got to be a NTP thing, or like the time. No, it's a time zone thing. Why does it think that I'm in? Oh, I guess it is UTC. Even though it says it's Pacific. Whatever. Fine. Okay. Go get our sample again. And just drop it here. Then we will reconnect over SSH. And we will use the, not this, we will use the, excuse me, the command that we got for enabling WMI tracing. No. And we'll do that, but we'll also quiet. And then we will also, oh, that was trace. I want operational as well. And I want Microsoft Windows task scheduler operational. And I want trace and okay. Is there a debug? I thought I saw a debug. There's a debug. Okay. So this is all enabled now. Wonderful. And yeah, let's do some crimes. Just confirm we've got telemetry. Indeed we do. It's a little late, but that's because I'm only doing specific things. We'll add ID 1 back in there. Crime doesn't pay out in the end. I mean, it depends how big the crime is, right? For example, sometimes in insurance fraud, not so much. But the continual rape of the planet by fossil fuel industry seems to be paying, unfortunately. You're mentioning that you don't see the PowerShell window to pop up, but because of usage, you can use the start process command and specifying the window style parameters hidden. Not really what I was talking about, JitCypher. I understand that you can do a window style hidden, but it'll still create a process. All right, let's is our time fixed? No, still like say 53. All right, let's fire this off. Polluted air. That's the weather condition in Los Angeles right now? Cool. Get out of here. Oh, no. They're not wrong. The air quality is trash right now. That sucks. Current air quality in Los Angeles. Anything above 50 is no bueno. Ugh. Don't love that. Let me just turn on my air purifying fan, which is a thing that we have because air's okay in here. The thing that we have because living in Los Angeles is quite the adventure. Isn't that the weather condition most days? It's not always this bad. And this winter has been pretty cold. So I think part of the reason why it's that bad is because everybody's using wood burning heat. You know, we should be seeing more data come in, and we're just not. Which is concerning. Yeah. The air quality where I live is 3. It's pretty awesome. Very happy for you. Last 30 days. Wait, why does it have stuff on the 22nd? Okay, well, hold on. Yeah, the temperature here is not that. Let's get rid of the event code stuff, just to see if there's any data coming in at all. 47. We would appear to be on a bit of a lag. Okay, the task exists now, though. So, elastic telemetry notwithstanding. Which is truly annoying. But elastic telemetry notwithstanding, we should have our event viewer be able to show us some cool stuff. So let's run this as administrator and see what the task scheduler has to tell us. And before somebody's like, well, why aren't you doing this with PowerShell? Because it's annoying. PowerShell is cool. Get win event log when you know what you're looking for, right? But if you've ever tried to use the filter hash table or the XPath method to filter data from win event log, it sucks. There's a perfectly nice graphical user interface. If the GUI is the right tool, there's no reason being elitist about it. I'm super elite because I never use my mouse. Microsoft Windows. Task scheduler. Hey, look, data. Into a system that didn't install the GUI on domain controller so that the help desk couldn't make changes without itself first. That's annoying. You know, it's funny. I have heard tell that the Genius bar used to be taught never to open the terminal in front of a user because they didn't want the user, the customer, to seem like, or to have the impression that computers are scary or that they were hacking something. I typically find a PowerShell solution for things not because of elitism, because I'm likely to have to do it again, and I like to not have to repeat myself when I can script or automate. I agree with you when it's something that you need to script or automate. In this case, I'm poking around. And in fact, I have a whole, thank you, Python for Defenders Part 2 automated message. I have a whole course that teaches you how to automate stuff like this, pulling events out of EVTX files and then parsing them with Python so that you don't have to do this kind of manual thing with a GUI. So I'm definitely on board with that, but I'm also not on board with, like, okay, let's see. Created task process. Test start. Task registration updated. In victim. Okay, so these task schedulers update, which is kind of interesting. Tasks started. I have to refresh cache. Here we go. Here we go. Created task process. So wscript.exe, task schedule launch task, connectivity emitter instance, wscript with process ID 5236, task registered. Here it is right here. Okay, task successfully finished. Instance of, the hell is this? No, that's wrong event. Task registered. Here we go. User SecLab registered task scheduler task conductivity meter. And that's all the data that we get from that. And we don't see, that was at 8:56:57. Okay, so if we go up to the security logs and go to the same place, there's nothing. And application won't have much for us set up. Is it going to be in system maybe? No, nothing. So that's interesting, right? Yeah, so this 856, this task registered, this is it right here. But we don't have any. The process ID was 1160, but this is from. I mean, that's like task host, right? All right, what does Sysmon show us at all at 8:56:57? Since time is the only thing that we have right now. Two things. At 8:56:23, we have wscript.exe kicking off. 8:56:57. And then there's the file that gets created. So it writes the thing, and then the very next thing that this sees is wscript kicking off. The very next thing. I am really at a loss here what this is doing to create this schedule task. But we do know that this is kind of a cool giveaway. Almost the negative space is interesting, right? If you see a file created in C Windows System 32 tasks without that ID 4698. No? Is that not the website? Yeah, it is. No. Reference. No. Wikipedia. There we go. $46.98. Right. And this is in It's no, it's security. So we're just not seeing it. So that's the thing. The missing part isn't the schedule task created after a login has been done after the infection, or maybe it just executes after the login. We just saw the schedule task registered in the schedule task debug log, but we saw it without the 4698. And we also saw that it's right here. Like, it exists. The task has been registered straight up. There it is, right? And the trigger is the logon trigger ID. So it's... Okay, now I'm just curious. Not task manager. How many times am I gonna do that? Task scheduler. Like, okay, so again, I want to try... Why are these so much bigger? They're a noticeably different size, right? If I import a task, what happens? But again, why didn't we see anything happen with like WMI or anything? There are ways to do this. Yo. Look at this. At 8:56:05 p.m., there was a usage of the scheduled task provider. Process ID was 1676, but that's WMI per SE. So this is all we see from it. Was that the scheduled task provider was fired up. But that does correlate our idea that it's using WMI, which was what I thought was happening, to do the scheduled task. So it's like... Can we do Windows script host logging? Is that possible? Script tracing and logging, not PowerShell. I don't want PowerShell. I want like W script. Yeah, Windows script host. No. Yeah, I think the only way to do this is to like reverse that initial JavaScript, which sucks. Okay. I want to kind of put a pin in that for now because I do want to see this other sample really quickly that our buddy Technique has provided for us. And so we are gonna roll back our victim. Hopefully not break Elastic even further. And so I have the sample here. Let's take a look at it first in Kali with Quackbot here. Let's extract it. Technique, if you're here. I don't have the password. Unless you put it in the email. Looks like Technique bounced. So I did want to try one more sample. Hey Wally, thanks for the follow. So we won't do that one. What we will do, however, is go over to triage and check out we'll do a quick Quackbot. You know, Redline Stealer has been around, but let's do family Quackbot. Let's see what you got for me. This one just came in today. I always like these because ISOs are interesting. Right, so I'm going to download this sample. Save it to bot. Okay. All right. Let's change our folder here. And here. So file.iso, 102.5 megs. This is about what you expect for one of these things. And then we have this WSF and Night. Bunch of text files, guildsman.txt. Very cool. Okay, let's go back up. Let's just extract this whole thing. Okay, so what do we have here? We have an HTML document, but is it really? Kind of. So the kickoff is night/data.txt. Function is new function A, reverse code. Hey, interesting. Wonder if this is real or somebody playing with us. .txt. Oh yeah. Okay, so one of the things we saw, just to start reversing this a little bit, is that new function A and reverse. So we're gonna reverse the code here in Vim. Clean this up a little bit. We'll remove those. Okay. And pipe that to rev. Thank you, Linux command line. And that is just easy as pie to read. Look at that. Let's change this to VB script. W script. Yeah. If you could reverse in Vim. Yep. If you can do it in the Linux shell, you can do it in Vim. Because what I did there was I used this command. The percent represents the current buffer, and then the bang will pipe it to the shell, and I just sent it to rev, which reverses text. Now we have hex to string, night armorial.txt. Ah, lovely. Okay, well, this is a job for CyberChef. Nope. DuckDuckGo sometimes, buddy. Yeah, there we go. What? That's new. All right. Hey, look at that. We have ourselves an executable. I will save that. Thank you very much. And this came from Armorial, so we'll call this armorial.exe.defanged. Yeah. Okay. So let's go back to our code.txt. So armorial.txt, it drops it to this i.txt. Hey, we're doing Quackbot now, but how does Gootloader get persistence? Little bit underpants know me at the moment, but step 1 is execute a JScript file. Step 2 is we know that there's a file drop to sysc Windows System 32 tasks called whatever. It's a random, or it's a hard-coded task name, but it's different for each sample that I've tested. And then there's a registered task, and that task fires up that registered task fires up PowerShell, which beacons out, waits for a command to come in, and then executes that via PowerShell as well. So not DLL injection, at least that I've seen, but again, there's this missing piece in terms of registering the scheduled task. We see the file drop, but we do not see the other components of registering the scheduled task. So I'm still not quite sure how that happens. Okay. Car code. All right. So it's creating the executable. Okay. So it's creating the executable. I don't know what you mean by event-driven, Yanner. We see the task get created and then triggered instantly. So there is some piece of, I believe that it's using WMI. Oh, that was the other part. Yeah, it is WMI. So the other part we saw is WMI events taking place concurrently with the task sched host.dll. Like, there is a WMI command getting run, but it's getting run in such a way that the normal stuff that you would use to look at WMI events is not catching it. Yeah, so it is that. But again, in a way that is a little bit obtuse to me. So, okay, or opaque to me. So then function read file name. So what is the rest of this? Because we have two other things. We've got a header here. It's just a bunch of A's. Okay, I think this might just be a spacer to make the ISO bigger. What is this? The absolute necessity of a solution to the transit. Wait, is this Kant? Is this critique of pure reason? Yeah. Unbelievable. Yeah, let's look for the absolute necessity of a solution to the transcendental problems of pure reason. Like, I'm pretty sure that's what it is. But it's like just part of it. That's very funny. Yeah, it's not all of it. Oh, cool. All right, that's it. Enough malware. Now we're going to be talking. Now we're going to be talking about Kant's Critique of Pure Reason and the problems of deontology. No. Oh yeah, that's why it's on project. It's why it's on Gutenberg. There's no DMCA for Kant. It's super public domain. This is just Spacer, I think. Unless there's... I mean, I would love for it to be true that, like... Yeah, I think it's just copy pasta, too. It's not... It's just bits of lines. But... Just to space it out. And we have these other folders. We've got Drake, Insatiably, Patagonia. These don't have anything in them. I believe these are simply to change up hashes, right? Easy ways to change up hashes. So we have this executable, though, right? This amariel.exe.defanged. And luckily, I have Cutter on here. So we'll fire up Cutter against armorial.exe.defanged. Just take a quick look. I wonder how bored they were when they did that. I'm sure it was automated. Okay. The usual nonsense. Hope this is not calc.exe in the end. You know, that's a good call out, ZM. Let's just fire off SHA-256 at this thing. And real quick, check it out. Virus total. Oh, why am I doing this in my proxy? There we go. I mean, it did score a 10. We got this from here. You know? If we look at the report from this thing, it did drop a file. And it is a DLL. Loads drop DLL. Yeah. Let me just do strings real quick. Strings and 10. Normal junk. We've got functions, of course. What in the world? Do you know what we are seeing? GDK, this has a GUI? This is graphics code. But really, like, huh? What on earth? What is this? This doesn't look like Quackbot. There we go. Maybe bundled with another regular binary? Maybe. Yeah. Because it's a DLL. It's 818K. Zemo. All right, well, let's put it into getting any data from our victim here. I want to check out. I feel like the timing on this got messed up. Analysis is unhealthy. It's fine. You're fine. All right. Still thinks it's 934. Usually Qbot is about 160 KB if you get it out of Explorer.exe or Word fault memory. I'm not sure that this is real. I have my doubts. It's marked as this, but I mean, it's weird, but it's weird in like the config extractor was real. All right. Well, one way to find out. Let's go put this thing on our victim. I'm going to restart the Elastic Agent just in case. Ah. Okay. Defender knows about that one. Simply will not have it. That's fine. We'll turn off Defender. Unless it wasn't Defender. It didn't ask for a password. Yeah, there we go. Cannot find script file. Yeah, there we go. Defender picked that right up. Okay. So we're gonna turn that off because it can't quarantine this. It's on an ISO. Things are happening. I'm getting no data at all. So KVM is Windows, sort of. Hey everybody. I'm not getting any data from the Elastic Agent. 13 months. How common is it for malware to automatically infect other machines? Automatically? That's a worm. So I would call that uncommon. Some ransomware can do it. Okay. I am so curious how we killed the Elastic Agent here. I think we maybe broke time was the problem. Unless it thinks it's like tomorrow. It's like, can I go into the future? So no data at all now. Yeah. Think we're done for today. We'll do some more of this later, but gonna blow away the lab here and see why I cannot get more telemetry. Why like the agent dies, because that's a huge pain. I can't have that happen. But yeah, so this was fun. Nice little bonus stream. Ended up being super long, but we found some good stuff about the Gootloader thing. We have a question to ask too, which is how the scheduled task stuff is happening. I mean, we know it's WMI, but how is it happening so that the logging is so light? But by the way, I will be back tomorrow. We're going to continue our work on the Throwback Network on Try Hack Me. So we're going to shift from blue team to red team tomorrow and hopefully get some good Windows exploitation going. So that'll be at 10 a.m. Pacific, 6 p.m. or 1800 UTC. So hope to see you there. Let's see if there's anybody else streaming. Nobody on knows, so and nobody in English. There's a French streamer and Spanish, but for now, I think we'll have you enjoy the rest of your day. So take care, everybody. Be good to yourselves, be good to each other, and happy hacking. We'll see you tomorrow.